Well, you may have noticed earlier there was another one of these expressions down here that are for us to evaluate. This time it's the cosecant of 105 degrees. And can we get an exact value there? And the answer, of course, is yes. We might note, however, that we don't have a formula down here for cosecant, so what to do? Well, we note cosecant of 105 will be exactly the same by our reciprocal identity as the sine of 105 degrees. So not bad right there. Of course, the problem is how do we get 105 degrees? Well, let's see. 105 degrees. We need a combination of a couple angles that we do know. One of them is probably going to have to be a second quadrant angle. Well, what's a good second quadrant angle right here? Well, 135 degrees. If we take away 30 degrees, we're going to get exactly 105 degrees. Now, this isn't the only combination that works, but it is a combination that seems pretty useful. So let's use it. Let's rewrite this as 1 divided by the sine of the sum difference, 135 degrees minus 30 degrees. And let's see what we can figure out from there. By our difference formula right here for sine, this is going to become the same thing as 1 divided by the sine of the angle 135 degrees. Of course, we know in the second quadrant, sine is always positive, times the cosine of 30 degrees. And we're going to subtract, because the sine stays the same right here, the cosine of 135 degrees times the sine of 30 degrees. All right, so we have to make a few substitutions in here to work this one through. Doing that, we're going to have 1 divided by, let's see how this works out, sine of 135 degrees. 135 degrees is a second quadrant angle, and 180 minus 135 gives us a reference angle of 45 degrees. So in the second quadrant, sine of 135 is positive, radical 2 over 2. I'm just going to leave it like this in the denominator until I'm done, and then I'll simplify at the end. Cosine of 30 degrees, we all know that's square root of 3 divided by 2. Cosine of 135 degrees, we're in the second quadrant, cosine is negative with a reference angle of 45 degrees, so this is negative square root of 2 over 2. And the sine of 30 degrees, we all know, happens to be 1/2. And so working this out, I'm going to bring it over here now, we have 1 divided by square root of 6 plus the square root of 2, all divided by 4. Or, stated another way, 4 divided by the sum square root of 6 plus square root of 2. I'm going to go ahead and carry out a rationalizing the denominator here by multiplying by the conjugate of the denominator. So the conjugate of the denominator just changes the sign between the two values that we're working with right here. So I'm going to multiply by square root of 6 minus square root of 2 in both the numerator and denominator just to see what happens. Square root of 2. Let's see. When I multiply square root of 6 plus square root of 2 times square root of 6 minus 2, that's going to be, in the denominator, 6 minus 2, the square root of the square root of 6, the square of the square root of 6 minus the square of the square root of 2, times 4 times square root of 6 minus square root of 2 for my numerator. Oh, hey, look, 6 minus 2 is 4. These guys cancel, and we're left with the quantity square root of 6 minus the square root of 2 being the exact value of the cosecant of 105 degrees. Pretty cool.